So today we'll be working with the Lunchbox plugin and primarily with the panel section and the structure section. So for today's exercise, we'll be creating a canopy that uses a space frame structure, which seems to be the most complex thing here, and panels on top, which will be focusing on the quad panels component, and then generating some columns to support this canopy. So it's going to be divided into 3 sections. First things first, we sort of have to create a form for our canopy. So how I have done it, and if you looked at the reference images in the email, I just created a long sort of flat plane. So I just used the plane command and then modified the shape of it using its control points. So if we were to turn points on in Rhino, you'll see that I have some control points at the corners, but I want to have more options, so more control points in order to manipulate the surface. So what I'll do is I'll select it and type the command rebuild. So this gives us options to add more control points or fewer. In this case, what we have initially are 2 in the U direction and 2 in the V direction. They're perpendicular to each other, and then you can decipher which direction it is through the red and green arrows. So in this case, I would like more in the U direction, just like that, and then maybe something like 3 in the shorter direction. So up to you to decide how you will divide your surface. This is what I'll go with. And then OK to accept. And I want this to be a little free flowing and have some curvature to it. So I've activated the gumball tool so that when I select my control points, I have the option to use these arrows to freeform my surface. So I'll let you guys, I'll give you guys a minute to sort of make a shape that you like to create a canopy, and then we'll move forward in Grasshopper.
Sorry, how do I turn my control points on?
Yeah, so I selected the object and type points on. Okay. P-O-I-N-T-S on.
Thank you.
Yeah. A bit too much. We'll keep it like that. Okay. So I'm happy with my surface. You guys let me know in the participants panel. Give me a check mark if you feel like you're ready to move on. Okay, great. So now that we have our surface, we're going to start applying these components to it. So we'll be grabbing a quad panel, and in our structure tab, we'll grab the first space truss structure. So obviously both of these require a surface input, which we created our surface. Now we need a container which holds this information. So we go to our parameters tab and find the surface container, and then we'll apply the surface to it. So let's right click it, set one surface, and select the surface that you've created. Great. I'm going to start off with the space frame structure. So what it's asking in its inputs is for U and V divisions and a depth for our truss. So we can use number sliders for all of these. And depending on how big you make them, will determine what like value you need for your depth. And for your divisions, we could do something like anywhere between 0 and 10. So I could press spacebar or double click for the search bar, and then simply type a value that's in between a multiple of 10. So if I were to press 7, I get a number slider that's in between 0 and 10. If I were to type 70, then I get a value between, I think, 10 and 100. So in this case, I'll just type 7 and enter, and I have a number slider now between 0 and 10 and set to 7. So I'll make a copy of it, Control C, Control V. For my V divisions and for my truss depth, I'll also have it as a value between 0 and 10. So we can copy and paste. And then lastly, insert your surface. So already just from this one component, we've generated quite a complex piece of structure that if you were to do this by manually in Rhino would take quite a bit of time. So this is one of the benefits of this Lunchbox tool alone, is that this structure component can create something as complex and precise as this to the surface very quickly. All right, so I'll let you guys determine what your U and V divisions are. With my surface, because it's such a long plane, I'll probably want more in the V direction, U direction, and then fewer in the V direction. So I'll just say like 5 and 10 for easy numbers, right? And then for my truss depth, that seems fine. Maybe I'll make it 8. Okay. And what you'll notice is that my space frame structure, at least, is on the top of the surface, and I'd like it on the bottom. And that's usually based off how you form your surface. So if there's more curvature to the bottom, then it will adjust to the bottom, versus if there's more curvature to the top, it'll adjust to the top. So if that's the case, we can go to the utilities panel here at the top right, and we'll select the component reverse surface direction. And so basically we can reverse which side this space frame structure will be formed on. And this will insert itself in between our surface and our truss, space truss structure component. So I'll reapply the surface to this input and take the output into here. Nothing has changed because we haven't really changed the options. We have 4 options, and they're all based off a value. So whatever you insert into here will be the value that we take. Or, so we could right click and set the integer. But if you want to have the freedom to switch between these 4 options whenever, instead of having to replace that integer value, we can go into our parameters tab, and under the input section, there's this component called value list. And it's sort of like a button that we could select from different options that we place into it. So when I take my, what's it called, value list component, we have 4 options already available. To edit this, we'll right click it, head to edit, and you'll see that now we have this text box, which on the right side or the left side, it'll display the name of the option and the result of the option on the right side of the equal sign. So in this case, I will change these values to 0, 1, 2, 3, 4 to follow what are the integer options in reverse surface component. And then this could be nothing because 0 will not make any changes. The second will affect the U. The third option will affect the V. And the fourth option will affect both the U and V. So I'll let you guys do that. Okay. So yeah, 0, it doesn't do anything. 1 reverses the U direction. 2 reverses the V direction. And 3 reverses both. And that should...
Can I see that again?
Yeah. So I'll go to right click and edit. And this is what it should look like. Whatever's on the left side doesn't technically matter too much. It's just the name. What we're most concerned of is on the right side of the equal sign. And these are the values that the component will recognize and place into this input.
So like with this value list, like basically 1 will automatically be U and then 2 will automatically be V.
Yeah.
Okay.
And then you could toggle in between these options freely instead of having to input it in manually.
Okay.
So if you feel like you're gonna switch it often, then this is a great component to use for an input. Okay, so I've inserted my value list component, and obviously nothing happens because we're at value of 0, which doesn't recognize a change. We could change our U direction, and as you can see in my preview, it's now on the underside of our surface. So in the participants panel, just let me know when you're complete. Cool. So now that we have our truss in the correct location, we'll now give it some dimension. So right now it's curves, and we could apply a pipe command so that it has now a circular structure to it. So in our output for the space truss structure, we have various lines that we are given. And so you can definitely just use one pipe component if you know that the radius will be consistent among all these outputs. Otherwise, you'll want to create a pipe component for each output. And so that I will do that actually. So I'm just copying and pasting them and then reapplying the output to each pipe. And these are way too thick, way too thick. So with my number slider, I'll have a value probably between 0 and 1. So I could type something like 0.5 and I'll get a number slider already with that range. So I'll copy these twice more and insert it to the radius. So I'll adjust the first primary lines and you'll see that we're affecting the top part of the truss. So we'll have something like 0.6 in this case. This will affect the bottom. So I'll keep these consistent, and anything in between, I'll do a little bit smaller, like 0.3. So that works for me. I'll give you guys a little bit of time to adjust yours. And lastly, with structure nodes, these are just points that are generated from the intersection of these, I guess, components in between the top and the bottom of the truss. So you're free to generate your own geometry at these points. An example could be a sphere, and that could represent the nodes. But I'll leave this as this for now. Okay, and I think that's pretty much all that's required for this space frame. Do you guys have any questions so far with what we've generated here? No? So a good good method for organization is to group your scripts or your sentence of components, so that once you start generating more, I guess, branches from your script, then you'll be able to easily identify visually what parts of the script are generating what material or objects in Rhino. So I'll select all my components for this base frame, and I'll right-click outside on the workspace and then group these, to which I could move these around now freely as one item, and even right-click to give it a name. So I will call it space frame. And another thing to mention is that every component, its preview is on. So in this case, I have my space truss, I guess, curve framework on, and that's not what I necessarily want to see. I want to see the final result, which are the piped objects of the framework. So in this case, I want to unpreview it. So I could select it, right-click it on the name or in the middle, and then unpreview it. And that helps to lessen the load on your computer, especially when you have a lot of solid geometry. So in this case, it's a curve. So it doesn't really affect it too much, but when you have a lot of solid geometries, that'll start to add up and slow down your computer. So make sure that you unpreview anything that's not really necessary. Okay, are you guys cool to move on?
How did you group the space truss elements? So
I selected all the components, and I right-clicked on the workspace. And then now we have a drop-down that gives us the option to group.
Oh, okay, perfect, thank you.
And then if you'd like to rename it, right-click on the group boundary, and then there'll be a free space at the top.
Yeah, thank you.
So now we'll focus on so we got our quad panel here. This also requires a surface, so we'll take this surface that we've created, apply it there, and now we probably want we want our panels to match our space frame structure divisions. So we can either copy and paste these ones that we've inserted into the space frame, or we could also just create a second connection to our quad panels. And then I hope you'll notice that the divisions are in line with the divisions of our space frame. In this case, our panels are intersecting with the thickness of the structure. So that's not going to work in real life. We'll probably want to elevate it a bit. So let's do a move command. So under, let's see, zip vector, no, transform, there we go. Transform and Euclidean, we can get our move tool. And so it's asking for our geometries. which we have, and it's asking for a vector, which we want to move it in the Z direction. So we'll also have to get a vector component, which you can find vector tab, vector panel, and we'll choose the Z direction. So this is going up. And lastly, we'll want to translate it a specific distance. So let's grab a number slider, and in this case, I want something between 0 and 1. So I'll type 0.5, and it'll give me a number slider within that range. We can connect these. And then lastly, our geometry to the panels. And I'll probably want a little more in this case. And now that we've moved it, we've created a copy essentially of these quad panels, 0.7 units in the Z direction, and I won't need this initial component. So I can right click it and unpreview it, and now we have just the geometry that we want. Okay, so that's super simple already. That I think we're basically done with. What we can do now is, it might be a little confusing since these are separate model objects, but they're all displayed visually the same. So we could go to our display tab and select custom preview. And you'll notice that this doesn't have an output. It's only an input component. And what this does, it provides a different visual display of whatever object it's connected to. And you could even give it a material. So right now it's the default at this pink color for my case, but it's a good way to differentiate these objects. Again, so let me know when you guys have caught up. And I'll do the same thing again as I did with the space frame. I will select all the components, right click outside on the workspace and create a group. And this one will be called canopy. So if you wanted to do something per panel, I would suggest, well, we're not going to do it in this tutorial, but I would suggest adding an area component. And what this area component does, it adds a center point to each panel, and that becomes kind of a good base to start adding more geometries or adjusting the panels to the way you want. So we could add this here, and now we have an area or a center to each panel. And this is really useful for a lot of geometries if you wanted to apply a point to it and it doesn't already have a point to start from. So the component is area, and you could find that in the surface tab under analysis. Right, and lastly, so we've got our space frame, we got our canopy, and because it's all deriving from this one surface, we can update it live and have this structure update to those changes. Lastly, we'll make a row of columns underneath that are our V columns. So first thing we'll want to do, oh, actually, no, I missed a step. I wanted to remove some of these panels actually and make openings. And if you recall from one of the previous tutorials, we looked at cull components, which you can find under sets and sequence. And so cull components are, they remove certain items in a list of data, and only retrieve the list, or only shows the items that have not been removed from the list. So in this case, I want to create an opening, in the middle of a few rows. So I want to take the call pattern component. And so this requires two items: a list of geometries that you want it to be affected, and a pattern in which it will determine if the listed item is shown or not shown. And we could do this through using text labeled as false or true, or because it's also a Boolean command, you could use 0 or 1s, and those also represent false or true. So in this case, we'll take the list of geometry from our move component. So that's the most updated version of our canopy structure. And as you can see, because there's already a predefined pattern, false, false, true, true, it'll show what panels are going to be visible. So because false, false is the first two items, we're not going to create panels from here, and then true, true. And just judging by how this pattern is shaped, we're reading the list of panels from left to right and then up and down. So I can insert my pattern by right-clicking on the input and setting it within my component. But I find an easier way is to use a panel and developing my pattern within the panel and visual, so I could see it from a glance. And in order to do that, we have to right-click the panel and remove these items: multi-line data and wrap items. So right-click and deselect those. And now it'll be in a format which is can be read by Grasshopper and input into this component. So if I insert it now, it doesn't have anything to read, so it's null. But I want to develop a pattern so that I could get my openings in the middle of every other row. So my first 5 lists, or my first 5 list items, will be false, 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 false. No, sorry. It'll be true, 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 because we want to keep these panels. And then the next 5 list items will be true, true. And for our opening here, it'll be false, followed by true, and then true. Is everyone following so far with that?
Yeah.
Yep. So because we don't have to do this whole list, we just need to know a point in which that pattern will repeat. So every 2 rows, the pattern will repeat. So I only have to have the list for these 10 items. So I'll try that out. I'll type true and then copy it 5 times for my first row. And then for my second row, I'll have first 2 panels as true, and then the middle panel will be false, not flash, false, and then followed by 2 more trues. And you can do whatever pattern you want. This is what I'm generating. And as you can see now, I've removed the center panels with this pattern. Again, now since this is the most updated version of our panels, we'll probably want to remove this or unpreview the move. So right click, unpreview. And now we have our desired canopy. So, yep, while you're figuring that out, then we'll move to the columns. So as opposed to this operation where we're where we're removing certain items in a list. For our columns, we want to retrieve specific items on a list. And those items will be points that we use to generate our columns. So in our sets panel, sets tab, we will choose, is it list item? I think it's list item. So we're going to, I think it's this one. Use the output of our space truss component. We're going to take the structural nodes and generate points in which we could draw our columns downwards. So we want to choose specific items of this node. So we're going to take the list of these, and right now you could see that because the default index is 0, which is the first index, is going to create a point there. But I will get a number slider and we'll do something like 70 so that we get a value between 1 and 100. Oops. And we're going to use this number slider to help determine which nodes that we want to grab. So in this case, I want a column, I want 2 columns that are sort of centered. And so if I were to zoom into this first row, I want one of my columns to start, let's say there on the 8th point. And our row of columns are going to be generated along this, this truss lengthwise. So what I will use now is a series component to create a pattern of numbers in which this list item can take these points from. So I will place this into my start input, and series will now go into index, I believe. Okay. And now we have to determine what will be our next, or like the spacing in between our column points. So I will take another number slider, and you can see that they're stepping about 8 from each other, but they're not corresponding in a line. So I'm going to adjust this number slider until these start to form a line, just like that. And so our step between my starting position and where I want another column will be 21 steps. And
yes, and if we want to skip some lines, so it won't be 21, then
it'll be a larger number.
42, or it will be 42, or it will be 63. So it will be like 42, I think. Yeah, 63. Yeah.
So in this case, it depends on your divisions of your space frame and your panels. So if you have fewer, then it'll be a smaller range for you to decide. In this case, it's quite a lot. So it was 21.
21, yeah.
Okay, great. And count determines how many we're going to create. So in this case, default is 10. I'll create another number slider for this. And I want it to just reach the end of our canopy. So I will want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Makes sense. Okay. Is everyone following along so far? So what I've done is I've made a list component that are taking from the data of the structure nodes. And we're using a series component to develop a list of items in which we want to extract these points. Okay, and I want a second column, so I'll do the same sort of operation. So I could copy these, and we're still taking from the same output data, structure nodes. This time I want my point to be on the opposite side of the opening. So I'll probably want this point here, and actually,
Eric, don't make them completely separate. You see, our steps will be the same. So the second slider will be the same. Number of repetitions will be the same. So you can reuse two steps and count sliders. You can reuse for both.
So we could do
yes.
this.
Yeah. And 21 also you can connect to both. Like
Yep, okay.
Yeah, and the starting, it can be independent or it can be just increment from 8, whatever you want. You can make it not 8 but 10, right?
You can make it like 12 or whatever. All right, and now we have our generated list of points in which we could start the top of the column. And now I need my notes. Okay. From there,
and now we need to calculate the projection, the foundation point, and it's the projection.
Yeah, so we're going to project our columns down to this base plane. And so you might want to lift your surface up if it's within that axis or base plane. So now that I have my list, I can project them to the surface. So I will get the project component. We're projecting an object onto a plane. And so our geometries are within these list items. And I can connect them, both of them. Now they should, have a designated spot on this work plane, which by default is XY, but if you don't have that, then you'll want to get the XY plane. So we have that. My column, it could be an ideal geometry, say a circle in which you can create a component from in Grasshopper, but I want this to be a little bit custom. So I'm going to create my own profile in the Rhino space. So you could do that too. I'm going to do like a weird curve, and I can't spell. I'm going to do this weird curve. Something like that. And that'll be the profile of my column. So as we did with the surface, we have to bring this curve in as a recognized Grasshopper information. So I could type curve or go to my parameters panel at the top to access this container. And then we could set our curve that we've generated here. As I mentioned with the quad panels, we can apply a center point to an object, and we'll do the same for this curve. So I'll grab the area component and apply a center to our curve. And now in order for this curve to apply to these points, we'll want to orient it. So we're going to take the orient command. And this will move our geometry from its original location to a target location. So I will place my curve into the geometry input. I will take the source is this center, and we have that. And then lastly, our project is our target. So I'll move all of these so it's easier to read next to our project component. And now we've reoriented our profile to each point that we've projected to the floor plane. And now, now that I have points on my canopy and points on the ground, I could connect them with a line, for example, and then use that line to help extrude these profiles. So I'll go ahead and do that. Our line, there's many different ways to create a line, but because we have 2 points, we'll use a line that has these 2-point inputs. Our first set of point values are under the project item. Okay. Thanks, Ilsa, for coming. So yeah, my first set of points are under my project, and my second set of points are in the list item here. So I'm going to apply that, and then these in the second. Okay, and help me out, Leo, because I forget.
I think you,
the
first of all, you need to connect both, and then you need to, you disconnect it first.
Oh yeah,
yeah.
We'll have separate.
Yeah.
Yeah, that's the reason.
Yes, it's better to have them separate. But
separate.
It was possible to do what you done. Yeah.
So we'll have our own separate items for these. And I'm a little bit messy right now, so I'm just uncoordinated. And okay, start point are these, and point is this. Okay, start point is
just
end point is this. Okay, is everyone on the same page?
Just a second to catch up.
Yeah. So what I've done is with my line, I've taken one set of my projected points into the start, and my list items, which are the points on the canopy at the end, and we'll do that the same for the second set. Yeah. So I'll give you guys a little bit of time to do that.
Yeah, Eric, and you will need to like the geometry of your bottom set. Probably you will need to edit.
I'll have to apply that. Yeah. Good catch. So I have the second coming to our target. There we go. And if you find yourself confused with these connections, which I do all the time, just simply double click it and you could create this little, it's called a relay, to help reorient it and make it a little bit cleaner. Okay. Oh, you guys are done? All right, and lastly, we just gotta extrude these profiles that we've made to our lines. Extrude curve. right? Extrude along. There we go. Extrude along. Our base is our geometry. And then we have our lines. And these are quite thick.
No, you can
These are quite
reduce your
thick.
curve. You can reduce your curve, like scale it down.
Yeah. Oh, it's so strange that that happens.
But, oh, you see one. Some of them are like different. They're going in different directions.
Yeah. So the reason why this is happening is because I'm not consistent with my inputs and outputs. So I have my list item on the first set going to the start, but then I have my list item on the second set going to the end. So
Yes.
that's just a place where I could readjust. And now they're both going in the right direction. So it's the other way, guys. It's the other way.
No, you can just multiply it by -1 and that's it.
Yeah, I could do that too, but I don't like extra components.
Yeah.
And now I'm like very confused. Okay. There we go. There we go. And I'll just adjust this a little bit too, because it's just so big.
I think your model with V kind of support was much nicer, but yeah, we don't
I think
have
so
time
too.
for that.
We don't have too much time.
Yeah.
Okay.
But actually, it's a very good example. Probably next time we need to go back and to make this V shape, because it shows 3D mathematics, like how you can calculate the average point. And I think it's important in Grasshopper.
Yeah. I think so too. I think so too. How is it going along with your models, guys?
Good. How would I be able to control the thickness of the column?
The thickness of the column is based off this profile that we've created. So that is something you'd have to adjust in Rhino itself.
Or you can introduce a scale component, and you can between, like, instead of the curve, you can put like after the curve you can put scale, and you can use a slider. You can use a slider to adjust the scale, and then you can scale your geometry up, like up and down interactively in Grasshopper.
Yep.
Okay, cool.
It's pretty cool. Center it
I don't, yeah, it's better to specify. I think the same thing as you did with area and centroid.
Center and then factor.
And factor, just connect a slider.
Yeah, let's do a slider. Let's do. Oops.
Okay, just make it floating number, not integer. Yeah, just redefine, like if you go to properties of the slider.
Oh,
like this number slider, yeah, and make it a floating number. Edit, and switch to R.
Okay, real number.
Yeah. Okay, and I think that this centroid thing
needs to be applied to here. So wherever your curve was applied to originally is where we'll replace it.
Yes.
And then now we could freely scale our columns based off this scale component. Yeah, and thinner the better. Almost no structure. Okay. Any other difficulties, guys? And then obviously organize this so that is really easy to read, and it's a little bit difficult at the moment here. So
on mine, there's a couple of columns that are going above the surface.
Above the surface. Okay, let's look at your screen.
Okay.
I'm sorry, I have to leave you guys. I have a meeting now.
No worries.
So, okay, see you.
Okay. Let's see. Can you zoom in a bit to the preview? And then let's look at the underside. Okay. Let's see. Geometry. Endpoint. Endpoint. Start point.
Yeah, I didn't rearrange those.
Okay. So I think, yeah, for your project, you see the two project components.
Yeah.
One geometry is going to the end point, and the other set, the geometry is going to the start point. So you might want to make that consistent.
Yeah.
I think that might resolve it.
Oh, okay.
Mm-hmm.
All right.
Okay.
And
And
sorry. On mine, like some of the columns are not going to the bottom, like they're not reaching the canopy.
okay, let's take a look at your screen now.
Okay.
They're not reaching the bottom of the canopy.
Like, I guess you can see it best on these ones.
Oh, okay. Interesting. Let's look at your script now. Geometry, endpoint, structure, nodes, strange, geometry, target. I'm seeing if mine also does a similar thing. Start point, end, curve. And then can we go to your model again? Weird. Can you select your line components on the Grasshopper face? Okay, and do the lines seem to be
The lines
reaching?
Yeah.
Yeah. Oh, okay. I don't actually know. Your script looks fine.
It almost seems like they're kind of like offset.
Yeah. So let's target geometry. Geometry and what if you just like took one component out and try redoing it?
Okay. Yeah, I can try that. Okay. Should I do it now or like later?
You could do it now or you could do it later, but
Okay, I'll just do it.
It's weird that it's not reaching, even though it should extend to the top of the line.
Yeah. That's okay. Like, I'll just try it later, I guess.
Okay. Right. And that's all I basically wanted to show you guys. When you're baking your components into Rhino, so just exporting or importing it from Grasshopper to Rhino, I would suggest making the layers beforehand. Otherwise, they'll all just go to the same default layer. So yeah, I don't think we've shown it in a tutorial how to bake, but it's really simple. So these are my components that I'd like to bring into Rhino. Right click on the middle portion, bake, with that little egg icon. I don't know why they have that, but yeah, so you'll have your list of layers, and make sure you organize that beforehand so that you don't have to so you have them all properly inserted. Otherwise, it's really messy when you bring it all in one layer in Rhino. Okay.
I have one really quick question. When I make a number slider, so do I type number slider and then enter?
What I do is, yeah, you could type number slider and then
Enter.
you can adjust it by right-clicking and going to the edit dialog.
Yeah.
But if you wanted the quick way, you could insert a number that's in between a range of, or a multiple of 10 range. So
Right.
you could do 0 to 10 would be 5, or 5 would be within 0 to 10. If you have 50, that's in between 10 to 100. If you have 0.5, that's between 0 and 1.
Mm-hmm.
And then you just simply click enter and it's there.
Okay.
So that's a really nice shortcut.
I have a question about baking. Like once you do it, can you undo it?
Can you undo it?
Yeah.
I would say undoing is deleting the Rhino objects.
But you could like also just redo, like you could change something and then redo it. Like
Yeah. Yeah. So baking makes it an non-parametrized, I can't even say it, object, and it just makes it a physical object in Rhino. And so if I wanted to undo it, I could hit undo, and that undoes the Grasshopper bake command. But then if you want to bake it again, make some changes, then yeah, that's possible. And then rebake it, bring it into Rhino.
Okay, perfect.
All right. Yep. So yeah, this is, I like Lunchbox already just from these two panels because I would have no clue how to do this in a very easy manner manually in Rhino, and the fact that you could constantly update this and have these changes apply to it is like pretty cool. So yeah, I hope you guys try to implement this in your projects because it's a really useful tool.